Hey folks, how's it going? It's Mr. Murray coming to you with a due now for Course 2 Honors. And this is for Thursday, June 4th, 2020. And wow, how quickly the week is flying. Perfect time for a little throwback Thursday. So I know yesterday our class and in part the hangout was devoted to factoring polynomials. So I thought to that end, because this factoring is going to be coming back in what we're doing right now, okay? It's going to be important to really get back to that factoring and give you guys a chance to practice with that. So what I want you to do, and feel free to go back to yesterday's materials and review those if needed, I want you to please pause the video, factor each of these polynomials completely, noticing that the last one is a challenge, and then when you're ready, unpause, and you can see what I got. The first one we have is 3x squared y minus 6xy squared. The only thing we can do here really is look for a GCF. So I notice that the coefficients, there is a greatest common factor of 3. And then if I look at the variables, these have an x in common, and these have a y in common. So what I'll do is I'm going to do 3x y, right? And then I'll open up my parentheses. So 3 times what is 3? Well, that's 1. So this will need to be an x, because 3xy times x is 3x squared y. And this will have to become a minus 2y. Now, if you put a 1 in front of the x because you're like, oh, well, this needs to be a 1 so I can get 3 times 1, that is 100% fine. You would still get 100% credit for that because they're mathematically the same thing. All right, moving down to the second, let's walk through the steps here. So the first thing we need to ask ourselves, is there a GCF that can be removed? And there is. Each coefficient has a 2 in common, right? 50 is 25 times 2, 20 is 10 times 2, and 2 is 1 times 2. And also, each term has at least one g in it. So this is g times g times g, this is g times g, and this is g. So if I take the 2 out of the 50 rather, I'm at 25. If I take 1g out of the g cubed, I'm at g squared. If I divide the 20, if I divide the 20 by 2, I get 10, and I take a g out, so that's 10g. Okay, and then lastly, I take the 2g out of the 2g, and all I'm left with is 1. Okay, now I come back. Okay, can I break this down anymore? No, it's 2g. Can I break this down? Well, does it have a GCF? No, there's not a g in all of them. There's not a number other than 1 in all of them. Is it quadratic? Yes. Can we try to factor it? Let's see. So I've got 25g squared. So it's 25g squared here, and I've got 1 here. So let's see if we can factor it. Now I notice that 25g squared is 5g times 5g, and 1 is 1 times 1. So since the first thing and the last thing here are both perfect squares, let's see if the whole thing's a perfect square. So I've got, if I plug that in, I get 5g and 5g, right? Because it's length times width. I add these up for 10g, so it is what we get. So we get 2g times, and if you don't want to do the box, that's fine. But if you don't want to do the box, you still have to have another method of factoring. Okay, and then you would want to rewrite that as 2g times 5g plus 1 squared. Okay, you do have to write that out like that because the fact that it is squared is important when we think about things like, remember we talked about multiplicity of solutions. The fact that it's going to bounce instead of go through. Whereas it's going to go through 0, it's going to bounce at -1. All right, moving on down, and I just noticed I didn't switch this to a minus. It's going to need to be a minus. This is going to be a interesting one here. So first of all, is there a GCF? There is not. there is not a number other than 1 that goes into all of the coefficients, and there is not an x in each of the terms, so at least 1, that is. So there's no GCF that can be removed. Now we go to quadratics. Is it a quadratic? No. So none of the quadratic techniques are going to work. Remember, this is something that should have been new to this year, right? Because then we talked about, well, is it cubic? Yes, it is cubic. So we could see if we can use one of the cubic strategies. Is it a sum or difference of cubes? No, it's not. So we can't use that rule. Is it groupable? Well, let's find out. So what I'm going to do is I'm going to break this up like this. And by the way, if you group differently than me, it doesn't mean that you're going to get the wrong answer. So I look at these two terms and I notice that they have an x squared in common. So I take out the x squared, and what's left? 2x plus 5. Imagine distributing the x squared in there. You would get back these first two terms. What's in here that's in common is a minus 4. So if I take out a minus 4, let's see what I get. So notice that if I distribute the minus 4, I get negative 8x minus 20. So I get exactly what I'm supposed to get. And notice that this is a 2x plus 5, and this is a 2x plus 5. Okay, so how many 2x plus 5s are there in each of them? There's only 1. So I remove that 2x plus 5 from each of them, factor that out, and then I do x squared minus 4. Am I done? No, because what I need to do is I now need to go through each factor and see if each factor here can be broken down more. So can 2x plus 5 be broken down more? No, it cannot. There's no GCF, and it's linear, so we're basically done. Can x squared minus 4 be broken down more? Well, is it have a GCF? It does not, but it is quadratic, and as it turns out, it is a difference of squares. So if you want to factor completely, you do need to do things like break it down as a difference of squares. And then I'd go through each one of these factors, and I'd observe that since there's no GCF and it's linear, right, the biggest power of x is 1, it is not factorable further, and so this is the final breakdown. All right, moving on to the last one. The only way we're going to be able to approach this is by using the rational root theorem. So remember, the rational root theorem begins by taking a look at the constant term and asking myself what numbers will go into it. So I could have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, because 2 and 3 go into it, plus or minus 6, plus or minus 7 does not, 8 does not, 9 does because 8 plus 1 is 9, 10 does not, and I'm going to stop right there. So, and then of course you've got in theory, right, you also could have some other numbers, but I'm going to stop at 9 because I'll tell you that what we're looking for shouldn't be going higher than that. Now what I do remember is I form my synthetic division table. So 1 minus 1 minus 4 minus 23 plus 27 plus 108 minus 108. So I form my synthetic division table, and then I'm going to take each of my guesses one at a time and plug it in. I'm going to start with 1 because I noticed something interesting about these coefficients, and 1 is generally a pretty easy number to plug in. So 1 comes down, I get 1. 1 times 1 is 1, plus negative 1 is 0. Okay, 0 times 1 is 0, plus negative 4 is negative 4. Negative 4 times 1 is negative 4, plus negative 23 is negative 27. Negative 27 times 1 is negative 27, plus 27 is 0. 0 times 1 is 0, plus 108 is 108. 108 times 1 is 108, plus negative 108 is 0. So that means that x minus 1 is a factor of this polynomial. I now need to interpret this to get what's left. So this is plus 108. So I've got to go, this is 1, 2, 3, 4. So this is x to the 5th plus 0x to the 4th minus 4x cubed minus 27x squared plus 108. Now the good news here is because I'm adding 108 as my constant here, I now need to repeat the rational root theorem, but the good news is it's 108 and negative 108. The factors haven't changed. They're still the same factors, okay? Because it's essentially the same number, except one's negative and one's positive. But that doesn't affect divisibility per se. Okay, so now I know that 1 went in. I can't, just by looking at it, I can see that negative 1's probably not going to work. So I'm going to try 2 as my next guess. So I'm going to first start with positive 2. So I plug in 2, and let's set up my synthetic division table. 1x to the 5th, no x to the 4ths, minus 4x cubes, negative 27x squareds, no x's, and then 108. So you've got to make sure you put in the zeros. So I bring down the 1, I get 1. 1 times 2 is 2, plus 0 is 2. 2 times 2 is 4, plus negative 4 is 0. So this will stay negative 27. Negative 27 times 2 is negative 54, plus 0 is negative 54. Negative 54 times 2 is negative 108, plus 108 is 0. So I've got now x minus 1, that comes down. This is x minus 2, because since 2 makes it 0, x minus 2 is a factor. And now what's left? Now I've got x to the 4th plus 2x cubed minus 27x minus 54. Okay. So now I would repeat the same process, and I'm going to assume 1s are out. And I'm going to try, just for the sake of trying it, I'm going to try now negative 2. So I plug in negative 2, and my synthetic division table goes like this. 1, 2, there's no x squareds, there's negative 27 x's, and so I'm basically just copying it from the above table. So 1 comes down, I get 1. 1 times negative 2 is negative 2, plus 2 is 0. Okay, 0 times negative 2 is 0, plus 0 is 0. 0 times negative 2 is 0, plus negative 27 is negative 27. Negative 27 times negative 2 is 54, plus negative 54 is 0. So I've gotten lucky here choosing correctly on the first guess, but generally the numbers are going to be pretty small. So I've got x minus 1 times x minus 2 times x plus 2 times, this would be x cubed plus 0x squared plus 0x minus 27. And finally, what we know about x squared plus minus 27 is actually, you can see that 3 will make it equal to 0. So for the last trick up my sleeve, I'm going to do 3, because 3 is a factor of 27. So I bring down the 1. 1 times 3 is 3, plus 0 is 3. Okay, 3 times 3 is 9, plus 0 is 9. 9 times 3 is 27, plus negative 27 is 0. So I get x minus 1, x minus 2, x plus 2, x minus 3, x squared plus 3x plus 9. And by the way, this is same, opposite, always positive. So you could have also used SOAP, difference of cubes, to get from here to here as well. So this is the final factorization. we know that x squared plus 3x plus 9 will not have a, this will not be factorable. And I know that because b squared minus 4ac, the discriminant is less than 0, right? 9 minus 36 is equal to negative 27. That's the discriminant, so therefore there's no way this thing is going to be broken down more. Remembering that this was obviously a challenge and where most of the time in the video went to. So if you're able to get these three right, we're going to continue to move on today to multiplying rational expressions, because we're going to move on with multiplying and dividing, with adding and subtracting, and then with actually solving equations. All right, best of luck today. Don't forget to love math, and remember, you can do it.